Assalamualaikum, welcome to our presentation for MAT 560, which is vector calculus. So I would like to introduce to our presentation, our presenter or my group members. So for the first one is, second one, third one, and the fourth one. And the last one is me, myself.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Kaya Fizi bin Aslan. So today I will explain about history 3 men and 2 theorem. Okay, the first one is Gauge Green. He was born in July 14, 1793 and died in March 31, 1841. He is English mathematician who was first to attempt to devise a theory of electricity and magnetism. This work heralded the beginning of modern mathematical physics in Great Britain. Okay, the second man is Sir Gabriel Stoke. He is born in 13 August 1819 and died in 1 February 1903. He was an Anglo-Irish physicist and mathematician born in country Sligo, Ireland. Stoke spent all of his career at the University of Cambridge, where he was the Lucasian Professor of Mathematics from 1849 until his death in 1903. The last man is William Thompson, was born on 20th June 1824 in Belfast. He was taught by his father, a professor of mathematics. In Glasgow, Thompson created the first physics laboratory in Britain. He was a pioneer in many different fields, particularly electromagnetism and thermodynamics. Next, I will explain about history of Green theorem. Okay, we can see that from the timeline 1793 until 1802. At some point, 1793, Gauge Green was born. He was later go to class during the year 1801 and 1802. This applied, he just got 4 semesters of formal tutoring at Robertson School in Nottingham. Not particularly is known about Green. Aside from that, he helped work in his private owned company. He more likely that not been dealing with math all through his time in a privately run company. However, it is modeled how precisely he ran over the high-level material he had learned. So this is a timeline about arithmetic development from 1823 until 1840. In 1823, Green joined a library in Nottingham and approached further development of arithmetic. In 1823, William Thompson republished Green work and he understood the significance of Green math. 1840, he distributed his own work, which was left almost unnoticed. Unfortunately, in 1845, he passed on. Next, we'll move to about history of Stokes theorem. Rediscovery of Green work lead to Stokes theorem. So we can see that from the timeline 1824 until 1903. In 1824, at 10 years old, he went to Glasgow University. I refer this to William Thompson. He went to the University of Cambridge. It is at Cambridge that Kelvin ran over Green work. So in 1846, Kelvin worked together with a man named Gabriel Stokes. So in 1854, Stokes chose to put the hypothesis as an issue on one of his tests. So unfortunately, it is hazy whether the hypothesis was ever demonstrated by one of his understudies. So in 1891, One of his hypotheses was confirmed by Hermann Henkel, and later on in 1903, Stoke died in Cambridge, England. Thank you.
Theorems gives the relationship between the integral line and the simple closed line, curve C in a plane, and a double integral on over R plane bounded by C. This is just a special two-dimension case of such a more general theorem of Stoke. Meanwhile, Stoke theorems give the relationship between a line integral around a simple closed curve C in space and a surface integral over a piecewise smooth surface. As we can see from equation 2 and 3, there are the similarity between them. The relationship between Green's theorem and Stoke theorem is Green's theorem in the plane is a special case of Green's theorems. Green's theorem refers just to two-dimensional vector field and to two-dimensional plane region. The theorem of Stoke is a Green's theorem to three dimensions.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So for my part, I will explain about 5 mathematicians and physics who contribute to the discovery of the theorem in a chronology order. The first one is Joseph Louis Lagrange. He was born on 21st of January 1736. He is one of the earlier mathematicians after Isaac Newton, who is the father of the calculus. Lagrange started his work at the age of 19, where he sent his work on calculus of variation to Leonhard Euler in 1755. Euler so impressed with Lagrange's work, then Lagrange was appointed professor of mathematics at the Royal Artillery School about 1 month later. Okay, so about the Lagrange, he then continued working on differential equation and various applications of mathematics, such as fluid mechanics. In 1764, he discovered a new theorem that was called as divergence theorem. For your information, this theorem not yet been proved because it takes more manpower to finally bring forth a proof. Hence, a few years later, the next well-known mathematician rediscovered the divergence theorem named George Green in 1828. So next, the founder of the Green's theorem, the one and only Sir George Green. He born in year 1793. He took in the formal education at the school of Robert Goddard in Nottingham for 4 semesters. Then he helped his family in running a business. Throughout his time in family business, he also working on mathematics. In 1823, he joined a library in Nottingham and had access a variety advanced mathematics books. In 1828, he published his own work that contained his theorem, which is Green's theorem. At that time, he doesn't consider that his theorem be the two-dimensional case of divergence theorem. Then he died in 1840 and his paper does not been realized by those people around him, as it was too advanced for that time, until 1845, that William Thomson republished back Green's theorem, and he realized that the importance of it. The third person in our corner is William Thomson, also known as Lord Kelvin, born on 26th June 1824, who is discovered the importance of Green's theorem, and he also found that it contained Stokes' theorem. He also a Scottish engineer, mathematician, and physicist, who is much popular and influenced the scientific thought of his generation. He attended Glasgow University at the age of 10 and attended the University of Cambridge in 1841. He discovered Green's theorem when he in Cambridge, and he became Cambridge lecturer in 1846 and collaborate with the one and only Sir George Gabriel Stokes. Kelvin and Stoke continued sharing their concept and idea about Green's theorem. In the direction of physics and engineering, Kelvin continued making valuable advance in the theories of heat, electricity, and magnetism. The unit of absolute temperature scale also named after Kelvin. Next is the one who proposed Stokes' theorem, named Sir George Gabriel Stokes. He was born on 13th of August 1819. He entered Bristol College in England at the age of 16, and later attended Cambridge University, where he met with William Thomson or Lord Kelvin. In 1854, he wanted to place one of his exam on the Stokes theorem as a concern. There is no evidence that his student can solve it or not, but in year of 1861, the first known published proof on the theorem was the Hermann Henkel. So the last person but not least that contributed with Green theorem and Stokes theorem is Hermann Henkel. He was born on 14th February 1839 in Halle, Germany. His father was one of the physics professors in Leipzig University. Hermann Henkel enrolled in Leipzig University in year 1857. He studied under August Mobius in mathematics and under his father in physics. In 1861, Hermann proved the Stokes theorem in the treatise on the motion fluid. Then Henkel received his doctorate in 1862 and began teaching in Leipzig University in 1863. Although Henkel did not live as long as other famous mathematicians, he would still be the first person who provided a valid proof of Stokes' theorem. So I will read back again the 5 mathematicians and physicists that contribute with the Green's theorem and the Stokes theorem. For the first one is the first one is a Joseph Louis Lagrange. The second one is a George Green, who proposed the Green's theorem based on the divergent theorem from Sir Lagrange. And then William Thomson, or called as Lord Kelvin. And the fourth one is Sir George Gabriel Stokes. And the fifth one is the Hermann Henkel, who is the first one proof for the Stokes theorem. That's all for me. Thank you.
Okay, next I will discuss about the role that Green, Thomson, and Stokes played in discovering this theorem and making them widely known. By 1837, Green took out the modest advertisement to announce its forthcoming publication. He chose Vanity Publishing and published out of the pocket an essay on the application of mathematical analysis to the theories of electricity and magnetism was written. One radical contribution from Green was his use of linear superposition to determine the potential of a continuous distribution, integrating the potential of a point charge over a continuous distribution. This was equivalent to defining what is today called a Green function, which is a common method to solve partial differential equations. A year after the publication of the essay, he began working on the mathematical problem with the support of Sir Edward Bromhead. Bromhead was a Nottinghamshire who had been one of the 51 subscribers to Green's published essay. In 1832, at the age of 40, George Green enrolled as an ungraduate student in Gonville and Caius College at Cambridge. Despite his concern over his lack of preparation, he won the first year mathematics prize. In 1838, he graduated as fourth ranker, only 2 positions behind the future famous mathematician James Joseph Sylvester. Based on his work, he was selected as a fellow of Cambridge Philosophy Society in 1840. Green had finally become what he had dreamed of being for his entire life, a professional mathematician. In 1841, Green died at the age of 49 and his essay was mostly forgotten. 10 years later, William Thompson was graduating from Cambridge and about to travel to Paris to meet with the leading mathematician of the age. As he was preparing for the trip, he stumbled across a mentioned Green's essay, but could find no copy in the Cambridge archive. Fortunately, one of the professors had a copy of that. He lent Thompson. When Thompson showed the work to Lovett and Stokes, it caused a sensation, and Thompson later had the essay published in journals, finally bringing the works and Green's name into mainstream. It was Green who first proposed the theorem. Thompson who realized the vast importance theorem of this power could have. Thompson then made this theorem well known through communication with others such as Stoke. Stokes used the theorem as problem 1 of his exam, and thus the theorem became known as Stokes' theorem. George Green, whom the Green theorem is named after, the form of theorem known as Green theorem was presented by Cauchy in 1846 and later proved by Raymond in 1851. The equation is named in honor of Green, who was the early mathematician to show how to relate an integral of a function over one manifold to an integral of the same function over a manifold whose dimension differ by 1. This property is consequence of generalized Stokes theorem, named after George Stokes, of which the Kelvin-Stokes theorem, the Divergence theorem, and Green's theorem are special cases.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Majami Besaifuddin from CS24954 for our term paper, which is three main two theorem. I will explain about for subtopic 4, which is investigation of electricity and magnetic lead to the discovery of Green theorem and Stokes theorem. For 4.1, explain how both theorem arise from the investigation of electricity and magnetism and were later used to study a variety of physical problems. Okay, first, for my research, an English mathematician, which is Green George, that was the first to attempt to establish the theory of electricity and magnetism. Okay, for this, Green almost entire self-taught in mathematics mechanics, and he was self-taught to justify his unique technique of solving physical problem. So Green extend and modify the electrical and magnetic investigation of the French mathematician Simon Denis Poisson in his essay on the application of mathematical analysis to the theory of electricity and magnetism in 1828. In the essay was applied to the present of mathematical research of electricity and magnetism theory. Green is the first exponent of mathematical physics in England, and all of his papers apply mathematics to the study and calculation of physical phenomena, which is electricity and magnetism, and the action of wave in fluids, and then sound and light. Okay, the test of electricity and magnetism was another unique aspect of the essay, which is the subject received as little interest in England in that time. Okay, not until the William Thompson began work on electromagnetism in 1840s, and the Faraday's more realistic work become known as that subject attracts to the general attention. In this essay also, the theorem is analogous to what we know as the Green theorem. It is reported, but not at the time of publication. It was not widely known. Okay, in 1832, Green submitted to the Cambridge Physiological Society a paper on the law of fluid balance, and in the following year, he submitted a paper on ellipsoid attraction. So both articles were published in 1833 and 1835. Okay, in 1839 he was elected to a fellowship in Gonvis and George College, Cambridge. Okay, he has written a future article on hydrodynamic, light reflection and sound reflection. Okay, for a fourth year after graduate, Green died leaving his essay behind. So William Thomson, Lord Kelvin, also studied at Cambridge and found a copy of Green essay in 1842-46. After fourth year graduation, Green died leaving his essay behind. So William Thomson, which he studied at Cambridge too, just found his essay in 1849. So he do the future work to future mathematician and make future advance in mathematics and physics based on Green essay. For 4.2, give 3 example and explain how the theorem is used to study those physical problem. Okay, there are many example application of this theorem have contributed to many application involve physics, mechanics, electrodynamic and electromagnetic. Okay, Stokes theorem, also referred as a Kelvin's theorem, is mainly applied to the topic of electricity and magnetism. It is found in the law of Maxwell, Faraday, and the law of Ampere. So in both cases, Stokes theorem is used to transition between the differential shape to the integral form of the equation. Okay, the differential form of radial law is one of Maxwell's equation. The theory of the equation can be used as the basis of the creation of electric generator and inductor and also transformers. Okay, next for the law of Ampere. A magnetic field integrated around the closed loop is usually correlated with the electrical current flowing through the loop. Okay, if the electric field is constant at all the time, then the law of Ampere apply. Okay, the magnetic field at the source is current density. Same goes to Faraday law. Ampere law also use Stokes theorem to transform the integral form to differential form. Okay, for the Ampere law is useful to the measurement of magnetic field is extremely symmetrical situation where the magnitude can be omitted from the integral due to the fact of the magnitude is constant along the boundary. Example of measurement of a magnetic field inside the long solenoid inside the conductor and extract more of Green and Stokes theorem example. In terms of singular, Green theorem transform the integral line into the double integral of macroscopic function, and also Green theorem can use to determine the mass or area and momentum to prove the law of Kepler to estimate the energy of the steady current. There are also application of Green theorem in classical mechanics, which is Liouville theorem or the hydrodynamic lemma theorem, also known as Kelvin hydrodynamical theorem. Okay, thank you.